Hello there, everybody. This is Mr. Longo, and it is time to talk about degrees and radians. And with degrees, we're actually going to talk about rounding all the way out to degrees, minutes, and seconds. And radians, we're going to introduce you to and talk to you a little about where they come from and how you convert between both of them. So, degrees, minutes, and seconds. If we think about the fact that a circle is 360 degrees, I want you to think about a clock. A minute is 1/60th of a degree. Okay, it's 1/60th of 1 degree. Now, don't really think about that in terms of like hours, because an hour is actually 30 degrees because there's 12 hours on a clock and 360. So think about it in terms of a minute is 1/60th of a degree. And then a second is 1/60th of a minute. So 1/60th times 1/60th is 1/3600th of a degree. So what's the point? Why do we need another way to round? And basically the real short answer is it's a much more accurate measurement, okay? So a lot of times, rounding doesn't make too much of a difference. If we're drawing a little triangle on a sheet of paper and we say one of the angles is 35.4 versus 35.3 degrees, it's not really that much. It's all dependent on the situation. So I want you to think about this. Think about your GPS in your car and latitude and longitude of a globe, and we've got this satellite up in outer space that's telling us where to go. Well, if you were off by 1 second, so we're rounding, we have an angle measure, and we are at 102 degrees and 45 minutes and 23 versus 22 seconds. If you were off by 1 second, you could be off by as much as 101 feet. That's a huge difference. So the reason we have degrees, minutes, and seconds is to get a more accurate rounding tool for degrees. Okay? So you don't really have to know anything fancy to do it, though, if you have a graphing calculator. So if you have a graphing calculator, let's show you how to use it. So 30 degrees, 0.3419. First of all, click the mode button. Your calculator must be in degrees to work with a lot of this trigonometry stuff, so just highlight degree, click enter, and then you can just press second quit, and you're back to normal. So how do you use your calculator to change a decimal into degrees, minutes, and seconds? What you do is you type in what you need, so 30.3419, and you just press the second button. And then we have apps, which right above says angle. So we go to angle, and then number 4 is DMS, which means changes to degrees, minutes, and seconds. Click enter, and we are going to find out that that is equal to 30 degrees, 20 minutes, and 30.84 seconds. Okay, but we're also going to teach how to round to the nearest minute. So 30 degrees, 20 minutes, and 30.84. So 30 is more than half a minute. 30 seconds is more than half a minute. So this would actually round up. So if we're rounding to the nearest minute, it's 30 degrees and 21 minutes. Okay, now the reason why I have the next example is just to show you the rounding difference, of course. If we were to do 30 degrees, 0.3413, and change that second angle, number 4, we would get something very close, 30 degrees, 20 minutes, and 28.68 seconds. This one would stay as 30 degrees and 20 minutes because 28 seconds is less than half a minute. Okay, so that's a little different. We don't look about 0.5s when we're rounding to minutes. We think about 30 seconds as half a minute. So if it's 30 seconds or above, we round the minute up. If we don't, we keep it as is. Okay? So what if we wanted to change degrees, minutes, and seconds into a decimal? Our calculator can do that as well. You just need to go back to that angle menu for 2 of them, and then the seconds is just kind of hiding. I'll show you where that is right now. So 45 degrees. So we would type in 45. And then go to your angle menu, so second apps. Angle is number 1, so that's our degrees. And then 33 minutes, so 33. Second, angle menu number 2 is our minute symbol. And then 14 seconds. There is no, for some reason, there's no seconds in the angle menu. There is, however, seconds if we click alpha plus. So I've got to go to the end here. Alpha plus. That's where the seconds are. I don't know why it's hiding over there, but it is. And then we can change that to a decimal. So the decimal representation of 45 degrees, 33 minutes, and 14 seconds is 45 point. And we usually round to 4 decimal places right now, so we're just going to do 5539. Okay, so knowing how to use your calculator is very important. If you are ever in doubt for angles, just remember, go look at the angle. It's the second apps button. That's where most of your stuff is going to be when we need to round with angles. Also make sure that you are in degrees, okay? So we're going to go talk about radians now. So let's think about radians. I mean, we know that a circle is 360 degrees, okay? But that's just kind of like the central angle. What if we want to talk about the outside of the circle? We know that to find the circumference of a circle, it's 2 times the radius pi. So the circumference is, in this case, 10 pi. But what if we were to divide that by our radius? We would have 2 pi. Let's do the same thing with the 10. This bigger circle is going to have a much bigger circumference. The circumference of this is going to be 20 pi. But if we divide it by the radius, we're still at 2 pi. So a full circle is 2 pi. Okay, which is, of course, 360 degrees if we're talking about degrees. But in radians, a full circle is 2 pi, which means half a circle is pi, also known as 180 degrees. Now, whenever you are asked to give an answer in radians, you must give an answer with like 2 pi, and we're going to talk about fractions of pi and all sorts of other stuff as this unit goes on. But what does it really mean? Well, if we were to take any circle of any size, and that was our radius, if we were to just take this radius and pick him up and lay him along the circle, so if this was like a string, it would take 3.14 radii to get around half the circle, and then another 3.14 radii again to get to the other half. So it's going to take 6.28 yada yada yada, also known as 2 pi radii, to get around a circle of any given size. And that's where radians comes from. Okay, so full circles 2 pi, half circle is pi over 180. So how do we convert from degrees to radians? Well, all you have to do is take your degrees and you multiply it by pi over 180. I mean, you could multiply it by 2 pi over 360, but that's a little bit more work than you need to. So for 30 degrees, we would just multiply by pi over 180. So that would be 30 pi over 180, but of course we're going to reduce. And you can just use your calculator to do that. So all you really need to do is take your degree measure divide it by 180, and click the math button and change it to a fraction. And we get 1/6, but our answer is pi over 6. Okay, the answer is pi over 6, not 1/6, pi over 6. So why don't you just figure out what negative 240 degrees is as a radian? And if you took negative 240 and divided that by 180 and changed that to a fraction, you should have negative 4 pi over 3. Okay? So that's how you convert degrees into radians. So how do you convert from radians to degrees? It's just the reciprocal. So we just take the radian and we multiply it by 180 over pi. So to convert pi over 6 to degrees, we just multiply by 180 over pi. And of course our pi's are going to cancel, and we're left with just 180 divided by 6. And sometimes you're going to have decimals, sometimes you're going to just have beautiful numbers. So in this case, right here, all you got to do, 180 divided by 6, and you probably already knew that was going to be 30 degrees. If not, now you know. And then the next one, same thing. You just have to multiply by 180 over pi. So we multiply by 180 divided by pi. Again, our pi's are going to cancel. So you just have negative 5/4 times 180. And we get negative 225 degrees. Okay, and that's it. So that's a video. It was a little longer than you probably expected, but we want to make sure that you knew how to work with degrees, minutes, and seconds, and radians. We're going to be doing a lot more with radians this unit, so make sure you know how to convert and understand the fact that a full circle is 2 pi. That'll help you out pretty great deal. All right, this is Longo, and I'm out. See you, bye.